Okay, let's look at example number 19. So this one is about constant head permeability test to get the hydraulic conductivity or permeability of the soil. As usual, feel free to pause the video for a couple of minutes and we'll be back in a little bit. Okay, so now we're back. And you can directly get the permeability definition or that equation for the constant head from the reference manual, and the reference manual for this one is actually pretty good. The K is Q over I times the A times T. So that is the equation you should use. So want to explain this for a little bit. So the Q is basically the volume of the water you collected. So this is the Q, and we have the time over here. And this is the head difference, and you have to calculate the A and the I. So the setup for this type of test is usually you have a container or a per meter. This is how I pronounce it. So you would introduce water from the top, maintaining a constant head. Over here, the water will be introduced from the top, and the water will flow out from the bottom, right? And because of the existence of the soil, we would have energy loss, or we would have the head loss. So one thing is you have to calculate this I. The I, definition of I, is the head loss over the travel distance of the water within the soil. So in this case over here, the head loss is 50 centimeter, and the travel length is essentially the length of the soil. So that is 30 centimeter. So you have about 1.67 of the hydraulic gradient, which is I. And you got to calculate the cross section as well. So the cross section is essentially the cross section of this container or this soil, and we have the diameter, so you can easily convert that to a cross-section area. So the cross-section area is about 176.6 centimeter squared. So now we have everything, so it's pretty easy. Just plug all these numbers in. We have 350 at the top. We have 1.67. We have 176.6. And we have a time. So just keep in mind that this is in minutes and all those answers in seconds. So you have a 5 times 60, convert the minute to seconds. And the final answer of this one is about 0.004 centimeter per second. So A is the right answer. So pretty straightforward. And there's another equation for a falling head permeability test, and we don't really have an example over here, but we might in the future. That one is another equation, a little bit complicated, but as long as you know what each of those parameters is, and you should be good. So yeah, that's it for this example number 19.